Saturn's rings are falling out of the sky. A rain of ice pours off them into the planet, and it never stops. Then NASA weighed what is left. The rings may be younger than the dinosaurs, and they are going. This is Cosmion. Point it at any question in the universe, and it will show you the answer, whether you can bear it or not. Today, Saturn's rings, the rain that is pulling them into the planet, and the measurements that say the dinosaurs never saw them. Saturn is the planet everyone can draw, a ball with a ring around it. Other planets have rings too, but nothing like these. Up close, the one ring becomes many, and the solid band dissolves into billions of separate pieces of ice, all circling the planet together. Most pieces are as small as grains of dust. Some are the size of a house. A few are the size of mountains. And they are all moving. Each ring circles Saturn at its own speed. Side to side, the rings span 282,000 kilometers. Top to bottom, the main rings measure about 10 meters, the height of a 3-story house. Scale that down until the rings are as thin as a sheet of paper, and the sheet is still almost 3 kilometers wide. Where did something that big and that thin come from? The honest answer is that nobody was there to see. The pieces are thought to be the remains of comets, asteroids or moons that came too close and were torn apart by Saturn's gravity. Whatever made them, the rings look like the most permanent thing in the solar system. They are not even close. The first hint that something was wrong came from a spacecraft that was not even looking for it. In 1981, Voyager 2 swept past Saturn and photographed its hazy upper atmosphere. In those pictures, 3 narrow dark bands circled the planet's northern skies. Nobody had drawn them there. Saturn had. At the same time, other instruments logged strange variations in Saturn's electrified upper air and odd patterns in the density of the rings. 3 oddities in 3 different places from one flyby. For 5 years, they sat in the data, apparently unrelated. Then a NASA scientist named Jack Connerney looked at where exactly the dark bands sat. They lined up with Saturn's magnetic field. Each band sat where a field line, running out through the rings, came down and entered the planet. In 1986, he published the idea. Electrically charged grains of ring ice were sliding down those invisible lines and dumping water into Saturn's sky. The falling water washed the haze out of the atmosphere at exactly those latitudes, leaving dark stripes. The bands were water stains. It was an elegant explanation, and it stayed unproven for more than 30 years. Saturn was leaking, or it was not, and nobody could tell. To catch the rings leaking, you first need to know what ring rain does to a planet. When the ice falls in and vaporizes, the water changes the chemistry of Saturn's upper air. One charged molecule starts living longer than it should. That molecule glows in infrared light. Where ring rain falls, Saturn's sky glows with it. In 2018, a NASA team led by James O'Donoghue published what the Keck telescope in Hawaii had seen. They found glowing bands in both hemispheres, sitting precisely where the field lines from the ring plane enter the planet, and the amount of water matched the rates Connerney had derived 32 years earlier. The 1986 proposal was right. Here is what those rates mean. Every half hour, Saturn swallows enough ring water to fill an Olympic swimming pool. NASA called it a worst-case scenario rate. From ring rain alone, the entire ring system would be gone in 300 million years. That sounds like forever. Saturn has already lived 15 times longer. But the rain was only half the story. The other half was measured from far closer, by a spacecraft that was running out of time. Cassini left Earth in 1997, took 7 years to reach Saturn, and then spent 13 years in orbit. By 2017, the tank of fuel it used for steering was nearly dry. Left alone, the spacecraft would eventually drift beyond control, with nobody able to choose where it went. so the team chose the ending themselves, while they still could. A fall into Saturn, so the spacecraft could never crash into a moon that might host life. In April 2017, Cassini was placed on a course that ended inside Saturn. But the road to that ending ran through a place no machine had ever been. The gap between the rings and the cloud tops. A corridor about 2,000 kilometers wide, with the rings on one side and the planet on the other. 22 orbits across 5 months, every one of them threading that corridor. The mission's project scientist, Linda Spilker, called it a calculated risk, skimming the atmosphere, skirting the inner rings. Her verdict afterwards was that almost everything found there was a surprise. Cassini flew where it was never designed to fly, and its instruments drank in everything. Inside the gap, it flew straight through the material falling off the rings and tasted it directly. There was water, as everyone expected. But there was also methane, ammonia, carbon monoxide, carbon dioxide, and complex organic compounds. The organics arrived packed inside grains of water ice just billionths of a meter across. Stranger still, near the rings, the falling material was ground so fine it behaved like smoke. Something is milling the rings into powder, and nobody knows what. In fact, the rings and the planet turned out to be wired together. Cassini found a never-before-seen electric current system connecting the rings to the top of Saturn's atmosphere. And the connection ran deeper still. Cassini found a second fall. At the equator, ring material was not spiraling down field lines. It was pouring straight in. Add both falls together, and as much as 10,000 kilograms of ring material is dropping into Saturn every single second. At that rate, the swimming pool from earlier fills in about 4 minutes. With that equatorial fall included, the estimate shortened. The rings may have less than 100 million years left. On the 15th of September 2017, Cassini made its final approach. It entered the atmosphere with its antenna held toward Earth, sampling the air and sending readings home, until its thrusters finally lost the fight. Then it broke apart and burned, like a meteor, inside the planet it had spent 13 years explaining. Cassini left one more answer behind, hidden in the way it fell. On every dive through the gap, the rings tugged the spacecraft from one side, and Saturn tugged it from the other. By tracking those tugs down to a fraction of a millimeter per second, scientists could do something never done before. They could weigh Saturn's rings. The result was published in 2019. Everything in the rings, together, comes to less than half the mass of Mimas, one of Saturn's smaller moons. Before Cassini, many estimates had imagined heavier rings. The measurement landed at the light end of expectations. All of that width, 282,000 kilometers of it, holding less substance than one modest moon. And for rings, light also means young. Ring ice is bright and clean, while dust from the outer solar system keeps landing on it, darkening it steadily. A ring system this light and this clean has simply not been out there very long. The analysis put its birth between 10 and 100 million years ago. The 2018 work agreed from another direction. If the faint C ring began as dense as its neighbor, it is unlikely to be more than 100 million years old. And in 2023, Cassini's dust counter added a third clock. At the measured dustfall, the rings can have been exposed for a few 100 million years at most. Now put those numbers beside our own planet's story. Dinosaurs lived on Earth from about 245 million years ago until 66 million years ago. If Saturn's rings formed at the young end of the estimates, the dinosaurs had already come and gone before the rings existed at all. NASA's own phrasing is careful. Saturn's rings may have formed during the age of dinosaurs, and if any of the young estimates is right, Saturn spent over 4 billion years bare. That is the finding. Now the honest footnote. Nobody has measured the age of Saturn's rings because an age cannot be measured directly. It is inferred from the mass and the dirt. In 2019, a group of ring scientists pushed back. Rings as old as the solar system are still possible, they argued, if something keeps them clean. So the young rings are the strongest reading of the evidence, not a closed case. What is not in dispute is the direction. The rain falls now. James O'Donoghue's team sees rings roughly midway through their lifetime. We are lucky to be around while Saturn has them at all. Jupiter, Uranus, and Neptune keep only thin ringlets today. If big rings are temporary, perhaps we simply missed theirs. The rain itself should have seasons. Sunlight helps give the falling grains their electric charge. So as Saturn's 29-year orbit tilts the rings toward the Sun and away again, the fall should change too. That is the next thing astronomers want to watch. And in November 2025, Earth was given a preview. Saturn leans by about 27 degrees, so as it orbits, our view of the rings tilts up and down. Late that November, the rings faced us exactly edge on, and because they are so thin, they simply vanished from view. That was only geometry, and the view is already coming back. But for a while, telescopes on Earth showed the other Saturn, the plain one. One day, the rain will finish the job, and the plain Saturn will be the only Saturn. So look again at the drawing every child makes. The ball is ancient. The ring is a visitor, and it is already on its way out. If you want one honest question about the universe answered every week, subscribe. Cosmion is already pointed at the next one. Next time, where the rings came from, and the moon Saturn may have torn apart to make them. That story starts with a world that no longer exists.